Comets are among the most spectacular wanderers of the solar system, and their glowing tails are what make them truly unforgettable. Yet, these tails are not permanent features. They develop only when a comet ventures close enough to the sun. At their core, comets are frozen time capsules, ancient bodies made of rock, dust, and volatile ices that date back to the birth of the solar system. For much of their existence, they remain quiet and inert in the outer reaches of space, preserved in regions like the Kuiper Belt or Oort cloud. But as a comet is pulled inward by the sun's gravity, the heat transforms its nature entirely. When a comet approaches the inner solar system, solar radiation begins to warm its icy nucleus. This nucleus, often only a few kilometers across, is made of water ice, carbon dioxide, ammonia, methane, and organic compounds mixed with rocky material. As the sun's energy seeps in, the volatile ices vaporize, changing directly from solid to gas in a process called sublimation. The newly released gases do not escape alone. They drag with them tiny dust grains embedded in the ice. This outflow of material forms a surrounding atmosphere around the comet, known as the coma, a fuzzy, glowing cloud that can stretch thousands of kilometers across. The sun's influence does not stop there. The powerful solar wind, a stream of charged particles flowing outward from the sun, interacts with the comet's coma, sculpting its material into distinct tails. Interestingly, every comet produces not one but two tails. The first is the ion tail, formed when ultraviolet radiation from the sun ionizes or electrically charges the gas molecules in the coma. These ions are then swept directly away from the sun by the solar wind, creating a long, straight, bluish tail that always points directly opposite the sun, no matter the comet's path. This explains why the ion tail often appears rigid and unwavering. The second is the dust tail, made of larger, heavier particles released alongside the gas. Unlike the ionized particles, dust grains are not as easily pushed by the solar wind. Instead, they are influenced more by the pressure of sunlight itself, tiny pushes from photons streaming out of the sun. As these particles drift away, their motion is also shaped by the comet's orbital path, giving the dust tail its broad, curved appearance. This tail often glows yellowish or white, reflecting sunlight, and can stretch millions of kilometers into space, fanning out behind the comet. Together, the ion and dust tails create the iconic image of a comet blazing across the night sky. They reveal not only the physical processes at play, but also a cosmic story, the fragile, ancient nucleus shedding material in a luminous display as it journeys through the warmth of the inner solar system. When the comet swings back out into the cold, far from the sun, its activity ceases, the tails vanish, and it returns once more to slumber in the depths of space, until gravity draws it back for another brilliant performance.